couple things that it does, but you do still need to be able to do these operations by hand.
Oh yeah, this was a...
Yes.
Are these snapping paper or on computer?
It's paper. Yep. Not like geometry where you have the county one. It's like our own exam. Okay. So what I need everybody to do right now is go ahead and turn your calculators on. Make sure it turns on, of course. Anybody need a calculator that did not turn on? Doesn't work? Alright. Okay. So, now that you have a calculator, I need you guys to click second. This is where you're missing stuff, guys. You're not paying attention. Second plus, and then 712. Good. And it should say RAM cleared once you do that. And then you're good to go. Okay? So you just want to make sure it's cleared out from whatever the last person was doing. Okay, so you see the first question on your notes. That's what we're going to be addressing first. So I'm going to pull that notes over so I can get a better look at it while I'm doing this. So you can see I have my own calculator on my screen here. You guys can see everything that's happening. The buttons are pretty much in the same spot, so you can follow along with what I'm doing. So the first question says, I'm sorry, it won't let me change the screen on the notes on this side. There we go. Okay, so the first question says we have a situation where we have a person hitting a baseball, okay? The x-axis is the horizontal height, so like how far it goes, the distance, and the y-axis is how high it goes up and down, okay? So the equation, we're going to go ahead and type that in. We're going to hit the y equals button on the top left. Once you click on that, you're going to type in the equation. Now this is the number one mistake I was seeing people make today. When you have to type in a negative number, make sure you hit this button that says negative, not the minus sign. So negative 0.000, or 00, just 10, I don't know why I did an extra one, 2. The X button, where it's the X, T, theta, N, that button right here. And then squared. And then it's plus 0.66 x plus 7. So did everybody get that typed in? Okay. Once you have that typed in, you're going to hit the button that says window at the top. And we're going to adjust the window to what it says to do on your sheet. So you're going to type in -2, not -2, but -2, arrow down, 500, arrow down, 50, -25, 100, and 50. So once you've adjusted the window to match the one on your notes, you're going to hit the graph button at the top right. And your graph should look something like that.
Can you go back for a second?
To the window?
Yeah.
It's right on your sheet. You see it?
Oh yeah.
Okay. So you're going to have something that looks like this. So now we're going to use this graph to answer some questions. So it says here, how far did the ball go? So the ball hits the ground right here, right? So I need to figure out where that is. So to do that, I'm going to hit this button up top called trace. You see that button that says trace on it? You're going to click that button and you're going to end up with a little cursor. And then you can hit the arrow button to arrow over to see what value that is at. So you're only going to be able to approximate, remember? So you're might not be able to get exactly to where we want. So it says, how far did the ball go? Well, it hits the ground at approximately, let's see, 340 feet, right? So 340 feet. So does anybody have any questions about that? Okay. Now the next one says, how high did the ball go? So to figure out how high the ball goes, we need the maximum, right? The vertex. That's right up here. So instead of estimating, we actually have a method we can do this exactly. You're going to hit the second button. You're going to hit the trace button. And you're going to end up with this list that says value, 0, minimum, maximum. You're going to scroll down to number 4, maximum. And you're going to hit enter. Now, once it comes up, it's going to say left bound question mark. You have to find that left bound, so you're going to arrow all the way over to the other side until you get to the left x-intercept. All the way over. So it's right there. Again, it's estimation, so it doesn't have to be exact. Get as close as you can to it. And then you're going to hit the enter button once you find the left boundary. Now it's going to say right bound question mark. You're going to arrow back over to the right side and find that boundary where we touch the x-axis on the right. Keep doing that until you get to the axis. And then once you estimate that, you're going to hit enter. It's going to say guess question mark, and you're going to hit enter to say yes, do that. And once you do that, it should find you a point right in the exact middle. Does everybody see that? That would be the vertex, right? So the maximum of this, the ball goes 61 feet high, right? Does everybody see how I got that? 61 feet high. So once you go ahead and fill that in, now we're going to go ahead and figure out how far did the ball go in terms of feet in the air at a height of 30 feet. So we basically want to figure out at 30 feet high, how far has the ball traveled distance-wise, okay? So here's how we can do that. You're going to hit the y equals button. So you're going to end up back here. You're going to hit the down arrow so you can type into the y sub 2 line. And you're going to type in 30 into that line, just like the number 3 says on the notes. Once you have that, you're going to hit the graph button again. And it should look something like this. Now we need to figure out what those two coordinates are where the two lines intersect, the quadratic and the line. So you're going to hit that trace button again. That gives you a little cursor. And then you can cursor over to both those values. So it looks like our y value is approximately 30 at x equals 41 feet. So at 41 feet distance-wise, we were at a height of 30. And is there another time where we also reach a height of 30 feet? On the way back down, right? So we can figure that out by doing the same thing, just arrowing over to the other intersection. So it's going to look something like this. So it looks like the other time that we were at a height of 30 feet was when we were 292 feet in to our throw, distance-wise. So does anybody have any questions about how I found either of those values? Okay, cool.
Would you round it up for x is 27? 292 on that board?
Yeah, 292. That's fine. I do want to specify that the exacts are not as important with this. Yes. You had a question?
Oh, no.
Go ahead. Oh, you write the 292 and then whatever the other one was, 41 I think it was? The x coordinate. Because the y is what we already knew. So now the question says, what would be a reasonable domain and range, right? So reasonable domain and range is what could actually happen in real life. So the domain is going to be the horizontal distance that the ball takes, right? So from here to here. So the horizontal distance can be anywhere from 0 when it's in his hand, the horizontal distance is at 0, until he releases it and throws it. And then the furthest it can go is whatever this x coordinate is, which we found earlier, didn't we? What did we find it to be?
340.
340. So our domain is going to be from 0 to 340. Now we're talking about range, which is how high it can go, right? So the lowest the ball could ever technically go is 0, right? If it falls on the ground, of course. And then the highest it can go would be our maximum, which is I think 60 or 61. Yeah, 61. So from 0 to 61 would be our range. So our range would be 0 to 61. And then for number 5, it says, what is the initial starting height before the ball was even hit? So let's talk about that. Now you could technically go ahead and trace and go back over here to see what the y-intercept is. But if looking at the equation, don't I already know what the y-intercept is? It's 7. So the initial height is 7 feet, which makes sense because if you think of somebody hitting a baseball, if they were like hitting upwards, say they're like 6 feet taller hitting upwards, that initial height when it releases from the bat would be approximately 7 feet high. It's a little, he probably was swinging really high, but you get the idea. Okay. So does anybody have any questions about this example? All right. So what I need you to do now is I need you to clear out that calculator again. Second plus 712. And it's going to say that. And then you can clear it out and you're back to square one. So now we're going to move on to the next example. We're going to talk about a jumping frog, okay? So, the first question about the frog, we're going to have to type in the equation, of course. So you're going to go to y equals, and you're going to type in negative 0.029 x squared plus 0.59x. Then once you have that typed in, you're going to hit the button that says window on it on the top. And you're going to adjust your window to the values it says in that box. Negative 2, 25, 1, negative 2, 5, and 1. So that's what it should look like once you have all of that typed into your window. Once everything is typed in, the equation and the window, you're going to hit the graph button. And you should end up with something that looks like this. Now that you have that, we're going to go through the same exact steps that we did earlier. It says, how far did the frog jump? So to figure that out, we're going to hit the trace button so we can use our little cursor. And I want to see how far the frog jumps. So that's going to be the furthest boundary over here. It's horizontal distance, right? So it looks like the frog jumped about 20 feet. You see that? About 20 feet. Now we want to do how high the frog jumped. We know that the maximum height occurs at the vertex, right? So to find the vertex or the maximum, here's the one that people seem to forget. So you're going to hit second and then trace. And you're going to end up at a table that says calculate. You're going to go down to number 4, the maximum button. You're going to hit enter. And then it's going to ask you to find the left and right boundary again. So I got to scroll all the way over to get the left boundary. So I get the left boundary, and then I'm going to go over and find the right boundary as well. So you approximate where that is, you hit enter, and then it's going to say guess, and you're going to hit enter again, and it's going to find the vertex for you. Once you find the vertex, we can identify that our maximum height is the y value, right? Because y is height. So the maximum height that the frog jumps is 3 feet. That's pretty high, actually, for a frog, right? So 3 feet is your answer for the height. Now that you've done that, you're going to go back to the y equals button. And it says to also type in a y2. You already have the y1 typed in. You're going to arrow down, and you're going to type in 2 for the second plot. Just like that. Once you have that, you can hit the graph button again. And it says, how far did the frog jump when it was 2 feet in the air? So we need to find where they intersect, these two, the graph of the quadratic and the linear. So you're going to hit the trace button once again. And you're going to arrow over to both those intersections. So that one, it looks like that occurred at 4 feet. So when the frog was 4 feet into its jump, it was at a height of about 2. And then go over to the other one and see what that one occurred at. And it looks like the other one occurred at about 16 feet into the jump. Was the other time that we reached a height of 2 feet. And then let's talk about reasonable range and domain. So domain is going to be whatever value from here to here. So from 0 to what? What'd you say? 20. Good. From 0 to 20 would be your domain, right? That's how far the frog went horizontally. And then our range would be from 0 to 3, which is how tall the jump was. And then lastly, what was the frog's initial height position before jumping? That would be whatever the y-intercept is. Does this graph have a y-intercept? Yeah, well, it technically doesn't have one written, so it's what?
Zero.
Zero. It starts right at the origin. Frog's really low to the ground. Okay? Yes.
So for number three,
Yeah.
what do you like write it in? Do you just write 2 and 16, or do you use brackets? Like, what do you do?
Oh, you can just write 2 feet and 16 feet. Yep.